So continuing on with the solutions for the end of year review number 1, which is all about solving stuff. We're going to move on to number 12. We need to graph the system of equalities. So you're going to pretend this is, for a little bit, it's just the equation of a line. So y equals negative x minus 1, which would mean the y-intercept was negative 1, and that you have a slope of negative 1. So you can get another point by going down 1, right 1, down 1, right 1, down 1, right 1, or you can go up 1, left 1, and just keep following that pattern. And so we know how this is going to go. But now don't draw the line quite yet, because when you look at this symbol, if there's an or equal to part of that, we can draw just a solid line. But this one doesn't, and so we're going to have to draw a dashed line along this trajectory here. And now we need to do some shading with it. So that one says less than, which means you need to shade below the line, which is down here. And I'm actually going to do that at an angle just to get a feel for that. Okay. And I'm going to graph this other one in a different color. I'm going to do this one in blue. This guy here, we're going to pretend again, it just says y equals negative 4x plus 2, which has a y-intercept of 2, and a slope of negative 4. So I'm going to go down 4, 1, 2, 3, 4, and right 1 to get another point. And that's actually the only 2 points that fit on here. And now we can draw our line because we have at least 2 points. This says or equal to on it, and so we're going to draw a solid line between these. If you have or equal to, you're going to have a solid line. And draw that line there. And this says greater than, which means we need a shade above the line, which is on this side. So I'm shading on this side. And it's good to make the answer region darker so you know which one it is. So that's this green section here. It's below the red line, it's above the blue line, and it's that section there. So there's our first one. Solving system equations, a lot of different ways, but this one's already set up for substitution, because right there it says y equals a certain thing, and then in this other equation there's a y, and so you can take this piece and put it in this part right there where the y is. And so I'm going to rewrite this second equation, but instead of having a y, I'm going to put parentheses 6x minus 11, because that's what y is equal to. And now you can distribute that through negative 2x. Negative 3 times 6x is going to be negative 18x. And negative 3 times negative 11 is positive 33. And now we can combine the x's to get all numbers on the right side. I'm going to subtract 33 from both sides just to get things on the left side, less on the left side. Negative 2 and negative 18 combined to give you negative 20x. And negative 7 minus 33 is negative 40. And now we just need to get rid of that negative 20 that's in front of the x. We'll divide both sides by negative 20. And it's awfully convenient that x is a whole number this time. Negative 40 divided by negative 20 is 2. So there's x, but we're not done yet. We need to take this x value and use it to get the y value. I'm just going to plug it into the right side here. I mean the x in this first equation. So a y value when x is 2, you're going to take x and put it where x is. And now you just simplify things down. 6 times 2 is 12 minus the 11 part, and you'll get 1. So y is 1. X is 2, and you're done. You got the x and y coordinates. There's another one. Oh, looks like we have another solve equations, and this one's not set up for substitution, but it is kind of lined up, so your y's and your x's are stacked up. And now you can use elimination on this. If you take this first equation and you times everything times 3, you'll get negative 15x and positive 15y. Oh, that was positive 15y, and then 60. We know how the first equation is times by 3. And now, if you were to subtract your equations, negative 15 minus negative 15x, negative 15x minus negative 15x would give you 0x, and so that's what I'm going to do. I'm going to subtract this entire new row here, and that's going to give you 0 x's, so there's no more x's, just so you know. And negative 8y minus 15y is going to give you negative, let's see, It's going to give you a negative 23y. And then on the right side, 14 minus 60. Alright, let me put this in. 14 minus 60. It's going to be a negative 46. And now we just need to get the y by itself by dividing both sides by what's in front of y, which is negative 23. And it's awfully convenient. That comes out to be a whole number. That's going to be positive 2. So we know what y is. And now we just need to take this y value and plug it into one of our equations. So I'm going to take 2. I'm going to plug it into this equation. Just plug in the second one. Doesn't matter which one. Negative 15x minus 8 times 2, because that's the y value you figured out, equals 14. It's going to give you negative 15x minus 16 equals 14. Now we need to get 16 on the other side. We get all the numbers away from x. We got negative 15x equals 30. And now we can divide everything by negative 15 to get x all by itself on the left side. And we get x equals negative 2. Moving on to the next part. We're going to write a system of inequalities to describe the situation. So Zach, buying chips and candy for party, can't spend any more than $36. Here, I'll kind of highlight some of the important things. No more than $36. Bag of chips are 2 each. Bags of candy are 3 each. What is this? Movie theater? Needs to buy at least 10 bags of snacks. Okay. So it's looking like we have some requirements here. We can't spend any more than $36. So our total amount needs to be less than or equal to 36. And okay, well that's fine. We just need to get a total here on the cost of things. Cost is what this one's talking about. Well, a bag of chips is $2 each, and x is going to be the number of bags of chips. Well, if you take the number of bags of chips, which is x, and you times by 2, that's the cost of all the chips. And y is the number of bags of candy, and those are $3 each. And if you do 3 times that, that gives you the cost of the bags of chips. So if you add all the costs of those things together, that needs to be less than or equal to 36. And he needs to buy at least 10 bags of candy for the party. So when you have greater than or equal to 10, x is the number of bags of chips, y is the number of bags of candy. If you add that up, you'll have the total amount that he has. And so here is our system of inequalities. We've met all the requirements. Moving on to 16, we need to find 2 different solutions to the system. Well, what I propose is just pick a few x and y values. So if we pick like 10 bags of chips and no bags of candy, like x equals 10, y equals 0, that fits this one because that'll add up to be 10, which is at least is greater than or equal to 10. And we plug 10 in here, that'll give you 20, which is less than or equal to 36. So this one works. And we can try it the other way around, like x equals 0, y equals 10. That meets this requirement still. And we do 3 times 10, you'll get 30, which is less than or equal to 36, so that one works as well. Moving on to the last 2. When you write a system of equation, describe situation. So Kirsten is going to sell tickets. First day, sold 5 senior. Here, I'm going to do X for the senior tickets and 4 student tickets. I'm going to say that's Y. So X is going to be senior, and then Y is going to be student. And that was $35 worth. Okay. I'm going to make dollars. Okay. And then the school ticket $76 on the next one. Yeah, that'd be a total amount there. I was selling 12 senior and 8 student. Okay, that's fine. Oh, so there's our system of equations. We got 2 equations, 2 unknowns. It's pretty good. 18, when you solve that system, we wrote to describe something. Okay, well, we can do that. If we take this guy here and times it by 2, then the y's are going to match, and I can use elimination method. So I'm going to have that be there, but I'm going to take the first one, times by 2, and that's going to give me 10x plus 8y. That's going to give me 70. And on the bottom row, 12x plus 8y equals 76. And now if we subtract those two equations, we'll get negative 6. The y's are going to cancel out. 10x minus 12x is going to give me negative 2x. Now if I divide both sides by a negative 2, that's going to give me x equals 3. So the senior citizen tickets must cost $3 each. And now we have that, we can take the 3 and plug it into one of our equations for x. I'm going to plug into the original x value there, so I'm going to plug in 3 for x. So that's the first equation, but 3 plugged in for x. This is going to give me 15. And now if I work on getting y by itself by subtracting 15 from both sides, I'll get 4y equaling 20. And you divide both sides by 4, you'll get y equals 5. So all the student tickets would cost $5. And that's the end of this assignment.